In this video, we're going to take a look at an example of Aitken's method. So we were going to take a look at this sequence here. So this sequence where p sub n is the cosine of 1 over n, starting with n equals 1. And we're going to find our first 7 terms of that sequence, and then we will do the same, but we'll find the first 5 terms of the sequence of Aitken's using Aitken's method for p hat. Right. So when n is equal to 1, we have cosine of 1 over 1, which as a decimal, that is about 0.54030. Then we have cosine of 1/2, which as a decimal is 0.87758. And cosine of 1/3, which is 0.94496. Cosine of 1/4 is 0.96891. Cosine of 1/5 is 0.98007. Cosine of 1/6. And this all is in radians, 0.98614. And cosine of 1/7 is 0.98981. So there we haven't used Aitken's method. That's just building this sequence right here that's defined by our nth term being 1 divided by a cosine of 1 divided by whatever that value of n. Right? So our values of n, as they went from 1 to 7, we had cosine of 1 divided by 1, and then 1 divided by 2. Right? And so now we're going to use Aitken's method. So we're going to apply Aitken's method here. So remember, Aitken's method is this. So when we find our first term of Aitken's method, we are going to take a look at the first term of the cosine, so cosine of 1 over 1, minus, then we are going to look at the n plus 1 term of the original sequence and the nth term, that difference squared. And then in the denominator, oh no. And then in our denominator, we're going to have all that mess. And so, when we roll through this process, we have our nth term, which is 0.54030, right? So that's our nth term, minus our n plus 1 term, which is right here. So 0.87758 minus the nth term, 0.54030 squared, all over the n plus 2 term, so we're going to go 2 up, right? So we're going to look at that 0.944, so this is in the denominator here, 0.94496, right? So the n plus 2 term minus 2 times the n plus 1 term, so 0.87758, plus the nth term, right, which was 54030. When you do all of that, you get something that's like 0.96178. So that's the first term in Aitken's method. Our second term, so when the value of n is 2, our second term, instead of starting with 0.54030, we're going to start here with 0.87758 minus the n plus 1 term. So one term, one step ahead. So the 0.94496 minus the current step, so the 0.87758. All of that stuff on top is squared. And then we're going to take 2 steps forward, right? 0.96891. Minus 2 times 1 step forward, 0.94496, plus the value for p at the current step, 0.87758. And if we do that, we get 0.98213. And I won't show all the steps for the next values, but our next 3 values, we get 0.98979. And then we get 0.99342. And 0.99541. When we calculated this third value right here made use of these 3 values, right? So our value for n are 3, 4, and 5. So n is 3, n plus 1 is 4, and n plus 2 is 5. Those are the values that are used here to calculate this value. And then for this value, we are using the 4th, 5th, and 6th term, and then we use the 5th, 6th, and 7th. We might notice that both of these are converging to 1. So this is getting closer and closer to 1. This is also getting closer to 1. Right here at this third term, we were already about as close as we were here at the 7th term down here. Now remember, that third term, it only took into account these guys right here. So that is Aitken's method and how we would apply it. In our next video, we're going to take a look at some other terms and methods related to Aitken's method. We will see you there.